All right, ready to dive in? Today, we're going to be really diving into AI that
These
sees,
two, at least, yeah.
learns to see. Yeah, we're unpacking convolutional neural networks.
CNNs.
CNNs.
If you want to, be
If
cool.
you want to sound cool, which
Right.
we all do, right? And these things are everywhere. I mean, you don't realize it, but
They're powering so much more than we even realize. Yeah.
absolutely. But let's back up a sec, right? We've all seen those Where's Waldo books, those
Oh, yeah.
those
Right.
busy images. Imagine trying to get a computer to find Waldo. Like we see the patterns, the shapes, but a computer pixels, just tons and tons of data points. And that's where traditional neural networks,
Your MLP.
yeah, your MLPs, they weren't really built for that. It's like the source we're looking at compares it to analyzing a book letter by letter
Yeah.
instead of reading the actual words.
Talk about inefficient, right?
Not very smart. And that brings us to, I think, a really big point, which is the computational cost. Like, we don't have unlimited processing power just lying around.
Yeah.
So how did CNNs come in and just change this game?
Well, I think, it's helpful to think about how we see, like we don't process an entire image all at once, right? Our eyes, they kind of dart around, we focus on areas, we connect the dots, and that's really what CNNs tap into. They exploit that inherent structure within images.
And this source, in particular, it calls out translation invariance. What does that even mean? In the world of CNNs,
So I guess it basically means that the location, it doesn't matter as much. So just like we can spot Waldo, whether he's hanging by the Ferris wheel or in a crowd, CNNs, they learn these features that are position independent, right?
so it's more about the pattern itself, not where it's at.
It's about recognizing the pattern, yeah.
Okay, so that's one big difference. What else makes them so good at this? At this whole seeing thing?
Well, remember how we talked about our eyes scanning, like focusing on these smaller areas to piece together this bigger picture? CNNs have something similar. It's called locality.
So instead of like getting bogged down by all the millions of pixels, they're zeroing in.
They're zeroing in on the important information.
That's clever.
It is. It's like they're breaking down this complex problem into these like bite-sized manageable chunks. And it's not only efficient, but it helps them learn these important patterns much faster.
Oh.
Yeah.
So we've got these CNNs mimicking how our eyes scan and focus, but what about color? Images aren't just black and white.
Right.
There's more to it.
Yeah, it gets even more interesting. So we all know RGB.
Red, green, blue.
Exactly.
Orange.
The building blocks of, of color images. Well, CNNs kind of take that concept and run with it.
Okay, so the source mentions this thing, feature maps. What are those, and how do they play into this whole color thing?
You can think of feature maps like these layers of analysis. Each one kind of builds on the last one to create this like richer understanding of what's going on in the image. Right. So it's not just red, green, and blue anymore. It's recognizing like textures, edges, shapes.
Eventually, like a whole object.
Exactly. Yeah, whole objects.
So the deeper you go in these layers,
yeah,
the more, I guess, complex and abstract the CNN's vision becomes.
Yeah, exactly. Like the first layer might be picking up on like simple edges and gradients, and then the next layer might take those edges and be like, oh, that's a texture, like that's fur, that's brick. And as you keep going, deeper and deeper, these features, they all combine, they interact until the network can, recognize a cat. And it doesn't matter what breed it is, the color, where it's sitting in the picture.
That's amazing.
It is really cool.
The source kind of goes deep on like the math behind this,
yeah,
the formula. I'm more of a visual learner. So
yeah.
Is there a way to wrap our heads around how these convolutions work without, all the equations?
Yeah, totally. So imagine placing like a magnifying glass over the image.
Okay.
And just like sliding it across section by section.
Right.
That magnifying glass, that's our convolutional kernel.
Right.
And it's the hero of our story.
So it's like if our image is, where's Waldo?
Yeah.
The kernel is like our little detective.
Exactly.
Yes.
Searching for clues.
It's looking for those clues.
Okay.
And the kernel is, it's designed to pick out specific patterns or features within each little section.
Mm-hmm.
So in Waldo, it might be trained to look for his red and white stripes,
His glass. Yeah, his glasses, his hat. Yeah.
Okay, I think I'm starting to get it.
Yeah, yeah.
So the kernel, it moves across the image, it analyzes each little piece.
Mm-hmm.
And then it learns to recognize those Waldo features, basically.
Exactly.
But how does it do that with millions of pixels? That's where I always get lost.
Well, so the beauty of this is that the same kernel, it's used across the entire image.
Uh-huh.
So this is where that translation invariance that we were talking about earlier, this is where it comes in.
Okay.
The CNN doesn't need to, like, relearn what a stripe looks like every time it sees it in a different spot.
So it's almost like it creates a template.
Yeah.
Based on Waldo's features.
Yeah, exactly.
And then it can use that template no matter where he is.
You got it. Yeah, it's this combination of the pattern recognition and this like spatial awareness that makes them so good.
Powerful.
And the best part, they're efficient too. Remember we talked about MLPs, how they struggled with all that data?
Yeah.
Well, CNNs, they have a secret weapon.
Don't leave me hanging. You were saying CNNs and their secret weapon.
Their secret weapon. So it all comes down to parameters.
Okay.
Which, those are like the internal, what do you even call them? Like the knobs and dials that a neural network uses.
To like make sense of the data.
To make sense of the data, exactly. And traditional networks, they need so many of them for images because they're looking at every single pixel like it's,
like it's the star of the show.
The star, exactly.
But CNNs, they're like, we've got this sliding window, so they're cutting back.
They're like, we only need the A-list pixels at this party.
Exactly.
Yeah, and the source even said, like, CNNs, they can sometimes get the same accuracy, right, as these traditional networks with, like,
no way.
10 times fewer parameters.
Wow.
Yeah, it's huge, especially when you're running these things on, our phones.
Oh, that makes sense.
Where every little bit.
Every bit counts, yeah.
Counts.
So we've got efficiency down, but there's this other word, right? Generalization. Sounds very...
very sci-fi.
Sci-fi, yeah. What makes CNNs so good at this?
Okay, so think of it this way. Generalization it's the difference between memorizing something and really understanding it.
Okay, yeah.
So a CNN, once it's, trained on enough images, it can look at a brand new picture and still get it right.
So it's not just like matching pixels up. It's learning, like, I don't know, the concept
underlying,
of what a cat is, no matter what it looks like.
Exactly. It's how Facebook knows to tag you in a photo you've never even uploaded, right?
Yeah, it is.
Like it's not magic. It's generalization through those, convolutional layers.
Wow. It's incredible. So we started with Waldo.
Yeah.
But it seems like we've hit on something bigger here.
Yeah.
And the source, it even mentions how CNNs, they're going beyond just images.
Oh, yeah.
What's next for this whole thing?
Well, it's cool, right? Because even though, they're famous for images, those same principles, the translation invariance, the locality, the feature maps, those can actually apply to like other types of data as long as it has, a spatial or sequential relationship.
To like audio waves, for example.
Exactly. Like instead of a grid of pixels, it's like a timeline.
Oh, okay, yeah.
So a CNN could learn to like pick out the word hello.
Okay.
No matter who's saying it.
Oh, that's cool.
By their accent.
So like Spotify, right?
Yeah.
Recommending music.
Yes.
It's taking that data.
It's all sequential, right?
Yeah, yeah.
Just like in images or an audio wave.
That's wild.
And CNNs can pick up on those patterns over time and, recommend your next favorite song.
So like everything from music recommendations to like real-time translation could benefit from this.
Absolutely. I mean, that's what's so exciting. It's like we've given AI this new set of eyes and, well, we'll see where they look next,
It makes you wonder, right? Like CNNs were really inspired by how we see. So what other senses or even like cognitive processes could we try to mimic to build, even better AI? So something to think about. Until next time on The Deep Dive, thanks for listening.